Alrighty, now we're going to balance some non-combustion equations, chemical formulas here. We still want to follow the chocolate rule in the sense that if there are any carbons, hydrogens, and oxygens, we want to balance them in the order of carbon, hydrogen, oxygen. So I'm going to skip the hydrogen for now and start with my phosphate. I'm going to look. So I have a phosphate on this side, which is a polyatomic ion, and I have a phosphate on this side, so it stays whole, which means that if I want to, I can balance the phosphate as a whole. I don't have to break it up into phosphorus and oxygen. All right, now I have a potassium here, so I'm going to write K, and then I want to do my hydrogens before my oxygens. And then I do have an oxygen right here that isn't a part of the phosphates. Do you see that? So here's an oxygen and here's an oxygen, and they're not a part of the phosphates. So they're separate. Okay, I'm going to write these the same way on the other side. So I have an easier time comparing numbers. All right, how many phosphates do we have in the reactant side? Well, we have one phosphate. Remember, because we keep it all together, it kind of looks like you have 4 oxygens and a phosphorus, but really what we have is one phosphate. One phosphate. We have one potassium. We have 4 hydrogens. So we have 3 here, and we have 1 here. And then for lone oxygens, we just have 1 lone oxygen. All right, let's come over to our product side. We have 1 phosphate. We have 3 potassiums. We have 2 hydrogens, and we have 1 oxygen. All right, so starting with phosphates, it looks like 1 and 1, so we're good there. We have 1 potassium here and 3 over here. So what can we put as a coefficient here that will multiply by 1 to equal 3? Well, we add 3. Now we did make some changes to our oxygen and a hydrogen, but we're not going to worry about that just yet. So now we're going to go to our hydrogens, and we do need to update our hydrogens with what we just did to our potassium and hydrogen and oxygen. So we have 3 hydrogens plus 3 hydrogens. So now we have 6 hydrogens on this side. And over here we have 2. So what can we put here that will multiply by 2 to give us 6? Well, if we put 3, that's going to give us 6. Oh, sorry. Now we have 6. Okay. We've made some changes to our oxygens, right? So we have 3 times 1. So we're going to update that to 3. And we have 3 times 1. So now let's check. We have 1 phosphate. We have 3 potassiums, 6 hydrogens, and 3 oxygens. This has been balanced. Okay, remember chocolate, because we do have some lone hydrogens and some lone oxygens. We want to always balance hydrogens first. So let's start with our non-hydrogen, non-oxygen elements. We have chlorine, sodium, and that's about it. So we're going to start with chlorine, sodium, hydrogen, and then oxygen. Chlorine, sodium, hydrogen, oxygen. Okay, how many chlorines do we have on the reactant side? I see 1 sodium. I see 2 hydrogens, 1, 2, and I see 1 oxygen. Okay, I see 1 chlorine, I see 1 sodium, I see 2 hydrogens, and I see 1 oxygen. Am I missing something, or is this already balanced? let's see. We have 1, 2, 2. Okay. 1, 1, 1, 1, 1, 1. Oh, this one's already balanced.